Welcome to Mr. AP. I'm Mr. R, and these are the 2025 FRQs for the AP Calc AB and BC exam. So the first FRQ is both an AB and BC FRQ, and it asks us about invasive species of plants, and it begins to spread, and we're given C of T, which is the number of acres. So part A asks us to find the average number of acres affected, and so the number of acres is C of T, so we just use the average value formula on C of T, and that's from T equals 0 to T equals 4. We plug that into our calculator, and we get that it's approximately 2.778. And so for part B, it asks us to find the time when the instantaneous rate of change of C, so C prime of T, which is already given as 38 over 25 plus T squared, is equal to the average rate of change from T equals 0 to T equals 4. So we equate these to one another, and then we set it into our calculator, and we get that T is equal to approximately 2.1543. So for part C, it asks us to find a limit expression that describes the end behavior of the rate of change in the number of acres, which is just C prime of T. And so we just write the limit as T approaches infinity of C prime of T, and then we evaluate it at 0 because T is in the denominator. As the denominator gets closer to infinity, it gets closer to 0. So for part D, it gives us a new function, A of T, and it asks us to find what time does A have its maximum value. So that's just asking to use the candidates test. And so we set A prime of T equal to 0, and then we plug that into our calculator and see what T value that is, and it's 11.4417. And then we also use our endpoints, T equals 4 and T equals 36. So we plug in those three T values back into A of T and see which one gives us the highest value, and that seems to be T equals 11.4417. For the next FRQ, this is a BC only FRQ. So part A asks us to find the rate of change of R with respect to theta on curve C, where theta is equal to 1.3. And we're given at the top that R of theta is equal to 2 sine squared theta, and we just take the derivative of that, so we get 4 sine theta cos theta, and then we evaluate that at theta equals 1.3. We can plug that into our calculator, make sure you are in radians mode, not degrees, and you will get 1.031. For part B, it asks us to find the area of the region that lies inside curve C, but outside the graph of R equals 1/2. So that's this area right here. So the first thing we have to do, we have to find the points of intersection. So we have to set 2 sine squared theta equal to 1/2. And then we get that theta is equal to pi over 6 and 5 pi over 6. So that's going to be our limits of integration. So we use the formula 1/2 the integral of r squared d theta. And we do the curve C, 2 sine squared theta minus 1/2, so that we can get this area that's shaded here. And then plug that into your calculator and you get 2.0668. For part C, it gives us that dx by d theta is 4 sine theta cos squared theta minus 2 sine cubed theta. And then it asks us what is the farthest point from the y-axis. So we have to find that theta value. So that theta value is, it's asking us to find this point that's the farthest from the y-axis. So it's the same thing as candidates test, that's what it's saying. So we have to set dx by d theta equal to 0, and we can see that theta is equal to 0.955317, and then we're also given the endpoints 0 and pi over 2. So we plug those three theta values into x, which is r cos theta, which we just multiply this 2 sine squared theta cos theta, that's our x. We plug that into our calculator, and at 0 and pi over 2, they are both 0. So which means that the maximum value has to be at theta equals 0.955317. And then for part D, it gives us that d theta by dt is 15 for all times of t, and it asks us to find the rate at which the particle's distance changes with respect to time, which is just dr by dt. So we're given r is equal to 2 sine squared theta, right? So we take the derivative with respect to time on both sides, so we get dr over dt is equal to 4 sine theta cos theta, and then we use chain rule, so we multiply d theta over dt, and we have all of these values. D theta by dt is 15, and then we're evaluating it at theta equals 1.3. We plug this into a calculator, and we get around 15.465. So FRQ3 is an AB and BC FRQ. We're given a table of t in minutes and r of t in words per minute, and we're asked to approximate r prime of 1 using average rate of change. So that's just r of 2 minus r of 0 over 2 minus 0, and the table says that r of 2 is 100 and r of 0 is 90, which is 100 minus 90 is 10, 10 over 2 is 5. So r prime of 1 is approximately 5, and it asks us to indicate units of measurement, which is words per minute squared. For part B, it says, must there be a value of c between 0 to 10 such that r of c is 155? So this is just saying we have to use intermediate value theorem for this. And for intermediate value theorem, you have to state that it is continuous. And the question states that r of t is differentiable, and differentiability applies to continuity. So it must be continuous. You have to say the first sentence on the interval 0 to 10. And so then by the intermediate value theorem, there must be a value of c such that r of c is 155. Because if we look at the table, we can see that r of 8 is 150, which is less than 155. But then r of 10 is equal to 162, which is greater than 155. So for part C, we just use the trapezoidal sum using 3 subintervals to approximate 0 to 10 of r of t dt. So we use the trapezoid formula 1/2 a plus b times height for the 3 subintervals. Okay, and then you can simplify it, but you can leave the top part how it is. But I simplified it down to 1252. For part D, we're given a new function, w of t, and we want to find how many words the teacher has read by the end of the 10 minutes. So we just integrate from 0 to 10 of w of t. And it's just power rule, and you plug in your limits of integration, and then you get that it's equal to 1,300 words that have been read by the teacher after 10 minutes. Okay, for FRQ4, this is also an AB and BC FRQ. So we're given the graph of f, and we're given that g of x is the integral from 6 to x of f of t dt. It asks us to find g prime of 8, so using the fundamental theorem of calculus, we can see that g prime of x is just equal to f of x, and g prime of 8, which is f of 8, we can see that is at f of 8 is just 1. And so for part B, it asks us to find points of inflections on g. So you have to use the second derivative for that when it changes signs. So I said g prime of x, which is also equal to f prime of x. We set that equal to 0. And so that's at -3, 3, and then also at 6. And so that's when they change signs. And so I said that g prime of x changes signs from positive to negative or vice versa at these 3 points. So find g of 12 and g of 0. So g of 12, which is the integral from 6 to 12 of f of t dt, that's just this triangle right here. So we just use the triangle formula 1/2 base times height, and we can get that it's 9. And then g of 0, which is the integral from 6 to 0 of f of t dt, is this semicircle here above the x-axis. I flipped the boundaries and then made the integral negative so that it's a bit easier. So the formula for that area is 1/2 pi r squared, and it's negative since I flipped the signs. So, and the radius is 3, So you get negative 9 pi over 2 for g of 0. And then part D asks us when g attains an absolute minimum on this closed interval negative 6 to 12. So again, this is also candidate's test. So our endpoints are negative 6 and 12, and g prime of x, which is f of x, is equal to 0 at the points negative 6, 0, and 6. So we plug in those 4 x values into g of x, and we can see that at negative 6 and 6, it's 0, and then we already found g of 12, which is 9, and then g of 0, which is negative 9 pi over 2. So g of 0 is the only negative number, so it has to be our absolute minimum on this interval. And so the fifth FRQ is a BC only FRQ. It asks us to find f double prime of 1, and we're given dy by dx. So we have to take the derivative of this and then also use chain rule. And then we get negative y squared plus 3 minus x times 2y and times dy by dx. And then we replace the dy by dx with 3 minus xy squared. And then we evaluate it at x equals 1 and y equals negative 1. And we get that d squared y by dx squared at 1, negative 1 is negative 9. For part B, we have to write a second degree Taylor polynomial. So using f to the nth derivative of c over n factorial times x minus c to the n, we can just use that formula, and then we evaluate it at x equals, or it's centered at, let's see, it's about, yeah, centered at x equals 1. So that's just f of 1 plus f prime of 1 times x minus 1 plus f double prime of 1 over 2 factorial times x minus 1 squared. And then we can see that if we simplify it, it gives us negative 1 plus 2 x minus 1 minus 9 over 2 x minus 1 squared. For part C, this is a Lagrange error bound question. We're given that f triple prime of x is less than or equal to 60, and we want to approximate f of 1.1. And then we have to show that using the error bound that the approximation differs by at most 0.01. So what I did, okay, so this is the formula, and then we did the second degree Taylor polynomial, and we're doing fn plus 1, so we have to do third degree, so we do f of 3 of x over 3 factorial, and 1.1 minus 1 to the third, and the question says that f of 3 of x is less than or equal to 60, so, and 3 factorial is just 6, so it's 60 over 6 times 0.1 to the third, which is just 10, and then 0.1 to the third is 1,000, so 10 over 1,000 is equal to 0.01. And then part D asks us to use Euler's method with two equal sizes, so 2 steps, and approximate f of 1.4. So it was a bit messy, so I don't think we had to simplify it, so we start with x equals 1 and y equals negative 1. We plug in those two into dy by dx. We get that's 2. The step size is 0.2. And so we multiply 2 times 0.2, which is 0.4. And then we add 0.4 to our original y value of negative 1, and we get negative 0.6. And then we do the same thing again. We plug in 1.2 and negative 0.6 into dy by dx. And then the next step, we multiply that by 0.2, and then we add negative 0.6 to 3 minus 1.2 times negative 0.6 squared times 0.2. That is what is approximately f of 1.4. So for the sixth FRQ, we have a Taylor series. Part A asks us to use ratio test to find the interval of convergence. So we use ratio test, which is the limit of as n approaches infinity of a of n plus 1 over a of n. And it simplifies, and we get our convergence as 1, or x is from 1 to 7. And then we have to see if 1 is included or not, and if 7 is included or not. So first we have to test x equals 1, so we plug that into our series, and we can see that it simplifies to -3 times -1 to the n over n plus 1, which is an alternating series. And so yeah, it converges by AST, and so x equals -1 or 1 is included in our interval of convergence. And then x equals 7, we plug that in, we get the series from n equals 1 to infinity of 3 over n plus 1. For this, I used the direct comparison test, but you could have also used the limit comparison test. So our simple series, 3 over n, diverges because it's a harmonic series. And even though b of n is greater than a of n, it diverges by dct. So 7 is not included in our interval of convergence. So there is our interval of convergence. For part B, we have to find the first three non-zeros and the general term of f prime about x equals 4. So we just take the derivative of these first three and then the derivative of the general term. It's, let's see, yeah, part B. I didn't really simplify it. I just used power rule and then left everything else. So that's what f prime is. And then the general term can simplify to x to the n over 3 to the n. Okay. So for part C, it says that f prime is a geometric series, and we have to see that f prime of x equals x minus 4 over 7 minus x. Because it's a geometric series, we can use the geometric series test. So we combine the series into one expression, so x minus 4 over 3 all raised to the n. And then the sum formula is the first term over 1 minus r. The first term is x minus 4 over 3 since it starts at n equals 1, not n equals 0. And then the r value is x minus 4 over 3. And then we plug that into the formula. I multiplied 3 by the top and bottom, and it simplifies to x minus 4 over 3 minus x plus 4. It's x plus 4 because the negative is distributed, and then that simplifies to x minus 4 over 7 minus x. And then for part D, we have the radius of convergence, and we have to see, does the radius convergence? So we have to see at x equals 8 if it does converge to x minus 4 over 7 minus x. So all we do is plug in 8 into our geometric series, but we can see that the absolute value of r is greater than 1 since it's 4/3, so the Taylor series diverges at x equals 8 by the geometric series test. So now we're on to the rest of these FRQs are AB only. So the second AB FRQ, we're given the region R and g of x and f of x. We can see that they intersect at 3, 3. So we have to find the area of R. So we just do integral from 0 to 3 of the top function minus the bottom function, which is the top function seems to be g of x. So we do g of x minus f of x, put that into your calculator, and you get 5.137. For part B, it says so cross-sectional perpendicular to the x-axis is a rectangle with height x and the base in region R, so we have to find the volume of that. So we just do the integral of what we just did, but we have to multiply all of that by x. So x times g of x minus f of x dx from 0 to 3 will give you 7.705. And then for part C, we have to write an integral expression for the volume when it is rotated about the horizontal region y equals -2. So that's this line right here, and because there's empty space there, we have to use the washer method. So it's pi times the integral from 0 to 3 of, so first of all we'll do the top one, which is g of x minus, so g of x is x plus sine pi x minus -2, the horizontal line, and then we square that, and then we do minus f of x minus the horizontal line -2, and then we square that, and then we integrate that from 0 to 3, and then yeah, we don't have to evaluate, just set up the integral. Then for part D, we have to find the value x at which the line tangent to the graph of f is parallel to the line of tangent to the graph of g. So it's just asking when g prime of x is equal to f of x. So we said g prime of x, which is given as 1 plus pi cosine pi x, and we set that equal to f prime of x, which is 2x minus 2. And then it has to be an x value from 0 to 1, so that happens at x equals 0.6758. Okay, the next AB FRQ is the fifth FRQ, and we're given two particles. We're given x of h and v of j. So part A asks us to find the velocity of particle h at t equals 1. So all we do is take the derivative of x of h of t and evaluate that at 1. The derivative is e to the t squared minus 4t, and then chain rule, so you have to multiply by 2t minus 4, and then evaluate that at 1, it's -2 over e to the 3, or -2 times e to the -3. For part B, what open intervals of time t from 0 to 5 are h and j moving in opposite directions? So we have to see when the intervals when v of h of t and v of j of t have different signs, so whether it's positive or negative. So for v of h of t, we set it equal to 0. We can see that t is equal to 2, and then we see how it behaves from 0 to 2, and we already know that v of h of 1 is negative, since it's -2 over e to the 3, and then we evaluate it at 3, and we get 2 over e to the 3, which is positive. And then we set v of j of t equal to 0, and we can see that we have t equals 0 and t equals 1, and it's negative from 0 to 1, and then it's positive from 1 to 5. So then the intervals at which both of them have opposite signs is from 1 to 2, because from 1 to 2, we have v of h of t is negative, but from 1 to 2 for v of j of t, that's positive. So they're moving in opposite directions on this interval. For part C, it can be shown that v of j of prime at t equals 2 is positive. So we have to see if the speed of the particle j is increasing, decreasing, or neither. So we have to see how v of j of t is acting at t equals 2. And we can see that both of them are positive, and because they have the same sign, that means the speed is increasing. For part D, it asks the particle j is at position x equals 7 at t equals 0, and we want to find particle j at time t equals 2. So this is just like fundamental theorem of calculus. We do, so x of 2 is equal to x of 0, the initial, which is 7, as it tells us in the question. Then we integrate v of j of t dt from 0 to 2. We do some u substitution, and we can get that x of 2 is equal to this right here. Okay, so moving on to the last FRQ on the AB exam. So part A asks us to find dy by dx is equal to this, and we're given an equation. So we have to use implicit differentiation for this. So we just take the derivative. Don't forget your chain rule when you're dealing with y. Then you factor out dy by dx from everything, and then divide 3y squared minus 2y minus 1 on both sides. And yeah, don't forget to move 1/2 x to the other side. And then you come with whatever is asked, so negative x over 2 times 3y squared minus 2y minus 1. So for part B, it says that there's a point P on the curve near 2, -1 with the x-coordinate at 1.6. And so we just have to use a tangent line approximation to find the y-coordinate of point P. So we have our derivative, and the points are 2, -1, so we input that for dy by dx, and it simplifies to -1 over 4, which is our slope. Then we use the tangent line formula. Our y1 is -1 and our x1 is 2. So we plug that all in and then replace x with 1.6. And then don't forget the approximately equals to sign. So y of 1.6 is approximately equal to -0.9. So for part C, it says we have to find the y-coordinate of point S, and which is on curve G. And so we have to see the line tangent to the curve at that point is vertical. So that just means that we have to set dy by dx, the denominator of dy by dx equal to 0. So we set this equal to 0. We factor 3y squared minus 2y minus 1. We get y equals -1/3 and y equals 1. But because the question said that x is greater than 0 and y is greater than 0, y equals -1/3 is not greater than 0, so it won't be included. So your y value is just y equals 1. For part D, we're given a new equation 2xy plus ln y equals 8. And then we have to find dy over dt at that instant. So this is another implicit differentiation question. So we have implicit differentiation, and then we have to plug in the dy by dx value that's given to us, which is 3, and then also x and y, which is 4 and 1. And then and then you simplify that, and you have 9 dy over dt is equal to -6. And so dy by dt is equal to -2/3.